In this video, what I'd like to do is explain key concepts of object-oriented programming and the way that you organize your code to design it so it has this thing called object orientation. The key concept that we're going to work with is this concept of organizing code. Now, what does that mean? It means that if we organize our code and the instructions that we write in certain ways, it gives us huge advantages for us as developers. So keep that thought in mind as we work our way through this, and let's start with a very simple example. Let's imagine with this simple example here that we have a roll of paper, and it's a bit upside down. You'll probably work that out in a second, but let's not worry about that just yet. And let's say that our instructions are written one line after the next. So there's an instruction, then it follows for another and another and another and another. And they just keep on going down the list and down the paper, and we just pull more paper as we need it, and off we go. So when you run the code, it sort of goes down in a single direction. Okay, first thing to note is that code, when we talk about code, we're really just talking about instructions. And these instructions are interpreted by the computer. Okay, so we want to write a chunk of code, I don't know, to add two numbers together, or to multiply one by the other, or to sort a sequence of numbers. So, okay, so there's lots of different purposes that you can put code to for coding. Okay, but what we're interested in is not the purpose, it's the way that we organize it. So this image here, where we write our instructions and our code in a single line, effectively, one instruction, then the next instruction. So we start here, follow that instruction, carry that out, then the next, then the next, then the next. Certain points we might stop, or we just carry on down the line as we go. There's a very crude image of how to organize code. It's hugely limited. And let's talk about one of the limitations. Let's change the color. Let's say that this little block here of code repeats itself, and I use the similar process further on down, and not just once or twice, but lots of times. My issue, can you see what one issue here might be? If I'm using it here and I'm using it here, and what I'm doing is either copying and pasting the code from here into here, let's talk about copying and pasting the same bit of code. Okay, that could be a simple way of doing the repeats, but copy and paste and copying stuff can always give you errors. And more importantly, isn't there a bit of a, let's use a different color, wasted effort here? Why should I repeatedly write the same bit of code, same series of, say there's another set of instructions which appear here and here. Why should I just keep on rewriting them as I need them? Surely there's got to be a much more efficient way of doing it. And the simple answer is there is. The first concept that we come across is this one called a function. We'll change the color because this particular green is a little bit on the dark side here. Okay, a concept of a function is, if you like, a way of grouping instructions that are related to each other. So if you took a simple piece of algebra, let's just take a simple straight line equation. Okay, that's not, the general one is no good. Let's just say that I have a formula here, so let's rewrite that. And let's say that I have a formula 3x plus 2. Now, if I interpret this crudely in terms of code and computing, let's say that I give you the value 2 and I want you to give me the corresponding value y. Okay, so there's my input and there's my output. Now, from a coding point of view, you can take that piece of algebra and break it down into a series of simple steps. And I'm going to make this very simple to explain how a computing concept of functions really arises, because it's a crucial concept. Let's say that step one is you multiply x, whatever value it is, by 3. Step number 2 is you add 2. Technically, there's a step before, which is you input your x value, and the very last step is you output your y value. So here we have a very interesting situation. This sequence here, let's say that I can just translate that into a block of code, a series of computer instructions. Doesn't matter what language it is, and I need it several different times like that. So one version of it appears here and it appears over here in my execution of my code. But this algebra gives you the idea that you can group sequences of instructions. So if you look here, there's a sequence of instructions. I can group them together and I can put them somewhere in my code and treat them as something called, let's use a different color, as something called a function. I've basically used the same color. Let's use a darker. The concept of a function allows me, as I said, to group instructions which are related. And so this example here of using a simple piece of algebra and breaking the business of recording a series of instructions in your code which appear here and which appear here. Now, it's simplified to some extent, because let's pose the problem that instead of writing the code here and repeating it here, I group them together, these instructions, this lot over here, and I put it somewhere else, and I give it a name. And with that name, I use the name here, the name of the function. I call that name of the function, and it runs these bits of code. I only have to write these bits of code once, and it'll save me a lot of time. So let's draw this on the next slide. Okay, so let's have a look at this situation here. Over here on the left-hand side is my series of instructions. At this point here, I need to take whatever value of x I have, pass it to something, and get a value of y, and then my code can continue. Further on down the code, same thing I need to do. I've got a value of x, I need to process, and I need to get back a value of y. So rather than write the code in this block here, why don't I create another file, and I take this function where you input x, process it by multiplying by 3 and adding by 2, and output the y. So there's my series of instructions and breaks that down. Why don't I work at it like this? That at this point I don't process it in the main code, I send it over to here, and this gives back the y value. Further down the line, when I need to use it again, I don't write the code again, I just simply pass the x value again across to the same file and this function, and it gives me back a y value. Wow, that means that I have enormously simplified my code, because the length of code down here actually shrinks. These bits don't need to have lots of instructions. The instructions are over here in a separate file. So I can build up a library of different functions in a separate file or in the same file, but we'll think about it in a separate file. And as and when I need them, I just use the name of the function. He says, writing that really messily in the corner. I use the name of the function, pass whatever I need to that function, it does its job and passes me something back. I can then continue. So now straight away, my program doesn't just simply behave, let's use a different color, it doesn't simply behave by just going down the line. At a certain point it jumps, goes across to another file, does something, comes back, then continues. Jumps, goes across and comes back. So the behavior of the way we've organized our code by splitting it in, and adding in this extra file which holds these little pieces of functions and instructions, it means that I can now save myself a lot of work. Look at what happens here. Here's my main code going down here. But because I've spent some time and I've written my own little collection of functions within a separate file, and this has a reference to it up here so it knows where to go, I can then just call the name of that function, get the function to do whatever it needs. So there's a function in here, there's function 1, does what it does, gives me back what I need. Do a bit of code over here, jump over here, come back here. So this is a first way of reorganizing code, not row, excuse me. It's a simple way of reorganizing code at what we say is a functional level. These are functions over here that we are going to group, design and work out. So we can design these. One part of our company could design them and build them. And every other part of our company, is a different color, could have a different piece of code that they need to use them in. So this is for one application and we could have a different type of use for another. But as long as we design and build this library here of functions, I have straight away a way of breaking up what you might call purely sequential programming. So let's capture this idea before we move on. So this model where code is written in a linear way is essentially a sequence. And what we are doing by creating a library of functions, let's just say there's a collection of functions, and we'll treat all of them like there's a collection, like a bunch of cards or even departments in a business. And I've written all these fantastic little functions which do this bit, and this one does something else, and this one something else. So I no longer have a sequential program, because at certain points in my program, let's draw it, say at that point there, I'm not actually running those 3 lines of code. I'm simply calling that function there and it's doing that. So this essentially, this breaks up the sequence of code. And this idea of functional, choose a different color, of functional programming in this particular way, at one level, it breaks up a sequence of code to allow you to call and use functions. The advantages are absolutely huge. It means that if you write a good library of functions, if this library is written really well, then the actual application you're writing and the things you need to do, you can literally pull in all these various functions and call these functions. These functions don't live inside this main program. So they don't just insert themselves in and add to the sequence. You call them and you jump to the function does its code, then it jumps back to the main code and execution. So this is a very, very important technique of non-sequential programming. The only issue here is that breaking things into functions is only half the picture. The other half is data. So let's have a look at this situation a little bit more. Let's say that I've created a bunch of functions. So there's one function here, and I've written another function over here, function 2, and each of them need to access data. And let's say that the data is stored in either a database or some kind of data structure, and each of these functions can directly interact with that database. So if I were to redraw how we drew our previous picture. There's my sequence of code, my main execution of my code. But think also, that's one person using it. Imagine I have another system where another person has started the application. So there's me, right? There's another person, and maybe there's a third person also running the application on theirs. Let's just sort of fill this in a bit. So there's a bit of code here, another call to another function perhaps, a little bit of code and so on. Over here, same kind of thing going on, different sections and styles of coding, same thing over here. So we have 3 programs, each of which are running at the same time. Now, let's just take this one. Let's take the very first one here. At this point in my code execution, right? Let's use a different color. Use red. At this point here, I don't run. I call this function here. This function goes to the database, gets me some data back, and does something with it, and then off I carry on. Meanwhile, this application over here, this person is using theirs, and they arrive at a similar point of their application over here, and they too call the same function, goes off to the database and comes back. Let's say that you're just reading data, not necessarily a problem, but let's say that in this third application, they actually want to update the data that they have. So they call this function over here. This then changes some of the data, tells you it's changed it, comes back here, and we carry on. Now the issue is here is that 3 points of access are going on, they're all going on at the same time. 2 separate applications are reading data using the same function, because this is a simple piece of code which gives you access, gives you a bunch of rules of how to access the data, so on, how easy it manages it for you and gives it back here. These 2 aren't necessarily a problem. The problem arises here is that there's a third person who is running a different function which is updating this database. Now, if they're updating the database and they have access to it, but independently of them, which is a different color, independently of them, this person over here is accessing that same piece of data. A problem arises straight away, that this person's data that comes back here may be corrupted. The person over here may access it 2 seconds later after the updates occurred. So they might receive the data here. And this person calls it when they're updating, problem, or they might call it before the update's made. There's a huge range of issues that come because this data is directly available. It's kind of on public view. It's like the department where everyone can speak to it and get what they need independently. All the functions do is just give me simple rules to help me access it. But that's pretty much it. The data exists separately, so anyone who needs the data can access it. And this is a huge issue for computer systems, because if 1,000 or 100,000 people access the data, then the potential to corrupt the data by someone updating it, other people accessing it at the same time, is huge. So this is the other part of it. It's not simply the final thing when you get functions and you've built up a brilliant functional library, because a lot of computer programs deal with data. So crudely put, functions are a huge step forward of breaking up simply sequential programs, linear programs, programs that just go down a line and on they go, as we've been drawing so far. But the other ingredient that most computer programs have is data. And simply bringing in functions will not satisfy the size and scale of issue if you're dealing with tons and tons of data, especially if that data is public and visible. The opportunity to corrupt this data, to get all your data and information messed up when hundreds of thousands of people are using the number of wonderful functions you've written to access data and do other things, you've got a problem on your hands. Now, what you may have noticed is that Functions break up code, but only at the level of instructions. What we want really to satisfy and to make our code safe again, what we want is some way of breaking up code where functions and data together can be linked. So the data that you need to access is wrapped up through a series of separate functions. You can't directly access the data, and the data and the functions are closely linked together in a separate sort of black box, if you like. So we want to group these things together, the data and the functions, and have a collection of them, just as we did before, but not just on the level of a function. We want to have function and data linked together. So if there's an important piece of data, you can't access it separately. It's not visible to the world. You have to literally go to the function, and the function will manage that piece of data for you and control who has access and how they have access. I want to build up a library at a higher level of these types of things. Now, they're not just functions, so this is not a functional library. So what kind of library am I talking about? Well, here we come to, choose a different color. Here we come to the concept of an object. In software, an object is essentially one of these. It's not just a function or a library of functions, i.e. a library of objects are not just simply a library of functions, but each object wraps up a block of data with functions that manage and control that access to that data. They always go together, functions and data, and that pairing together of these gives you the ability to create much more complex programs, which we'll go into just in a moment and show you how. And we call them an object. So what we are talking about now is creating a library of objects which will help us sort out the problems we identified in the previous video. So this is a very brief introduction of object and functional programming, and how these concepts have developed and the issues that have brought them around. We began this video by talking about the issue of organizing code in ways that allow us to reuse code, save repetition, break up linear sequences, linear code, and so on. And so the first concept we used to organize was on the basis of functions. Each function being written separately, and you get a collection or a library of functions and use them when you need them. But that only took us part of the way. It is a perfectly legitimate way of programming. It took us only part of the way. The next step was to actually reorganize code in terms of objects. And the object links a function, crudely speaking, and a bit of data. And so you create a library of objects, each of which is managing data within that object. And this way of organizing code is called object-oriented programming. It's non-sequential, and it allows you to build up more complex programs and manage them, especially with data, more effectively.